What is kinematics? Kinematics is the study of motion without asking why, without reference to forces which cause the motion. What kinematics is concerned about is where something is moving, how fast it's moving, and how the speed changes. We don't care about forces, about mass, and about energy. So, none of these. And we do hear about where So what are the physical quantities that we need? First, we can start off with position. Position is where an object is on a number line. We usually call it just X. And this is in 1D motion. And it's measured in meters. Now, from here we can also discuss displacement. This is the change in position and is represented as delta x is equal to x minus the x initial. And displacement is signed, and also the direction matters. Moving on, we have time. Time is how long something moves. And we represent this as delta t is equal to the time minus the initial time. And usually we set t initial equal to 0. Now, from here, we can discuss velocity. So velocity tells you how fast and which direction, position changes. Now for your average velocity, this is delta x over delta t. And velocity is instantaneous. And in AP Physics 1, we treat velocity as changing linearly. Now, acceleration, it tells you how velocity changes. And this is represented as A is equal to delta V over delta T. And in kinematics, the acronym CAKE represents constant acceleration kinematic equations. So essentially what we'll see is that all of the kinematic equations, they have the assumption that acceleration will be constant. And this is required for the kinematic equations to work. Now, two definitions that everything comes from will be the definition of velocity and the definition of acceleration. Now, knowing these two, we can now derive every single one of the kinematic equations. Now, we can start off with V is equal to V theta plus AT. To get this, we can start from the definition of acceleration, which is velocity minus the initial velocity. After this, we can multiply both sides by t, and we're left with. Now, if we add v initial, then we have v is equal to v initial plus acceleration times time. Which is our first cake equation. Now, this says that velocity changes linearly with time. And also that a constant acceleration adds the same amount of velocity every second. Now, for our second kinematic equation, we start from the definition of average velocity, which is equal to the initial velocity plus your new velocity divided by 2. And we have that displacement is delta x v average times t. Now, using this, we can substitute in v average. So we have delta x is equal to v initial plus v over 2 times t. Now, we can substitute in v is equal to v initial plus at. And we have that delta x is equal to v initial plus acceleration times time divided by 2 times t. And this gives us delta x is equal to 2 times v initial plus the acceleration times time divided by 2 times t. And now from here we can cancel out. So we have delta x is equal to v initial c plus 1/2 at squared. See, that multiplies And we can see here that if we split this up into two fractions, if this is easier for you to visualize. Will become that. That becomes 1/2, and that 2 cancels out. So this is where we get our second kinematic equation. Now, for our third kinematic equation, this one is important because it has no time. So we can start out with velocity equals to v initial plus acceleration times time, which was our first kinematic equation. And from here, we solve for time. Now we can plug this into the displacement equation. Delta x is equal to v initial plus v divided by 2 over time. Now, instead of time, we can use this entire expression. So we'll have delta x is equal to now from here you can recognize that this is a difference of squares, more particularly here. So this is a difference of squares. We can rewrite this as v plus v initial, v minus v initial. So knowing that, we can FOIL this. So we're left with v squared plus v minus v initial squared. Now from here, we can write that delta x is equal to v squared minus v initial squared divided by 2 times the acceleration. Now from here, we can multiply both sides by 2a. And now from here, we have that expression 2a delta x is equal to v squared minus v initial squared. And you can add v initial squared to both sides. So you're just left with v squared is equal to v initial squared plus 2 times the acceleration, x minus x initial squared. And this is your third kinematic equation. For your fourth kinematic equation, you're going to use the definition of the displacement under constant acceleration. So, well, that's what it's going to be. So we start off with average velocity. We know that was v plus v initial. So that's the velocity you're at plus the initial velocity. And you take the average of that, and then you can multiply by time. And we have that time is equal to this. So then we have that x is equal to x minus x initial is equal to 1/2 v plus v initial times t. Well, we can use, actually, you can say that v average is equal to delta x over delta t. And then instead of this, you can multiply by, you can just say time instead of that. So then after that, you can rewrite delta x as this expression here. And then this is what you're left with by moving the 1/2 out front. Now, why is there a 1/2? Well, this is because velocity increases linearly, and average velocity is halfway between the start and end. And graphically, this is going to be the area under a straight velocity time graph. Now, there are other kinematic equation forms that you may see, but these are just different algebra variations. For example, you might see v is equal to acceleration times time, x is equal to 1/2 at squared, v squared is equal to 2a delta x is equal to 1/2 vt. And all of these come from setting v initial equal to 0. Now there are also algebraic rearrangements. So for this, you could also rewrite this as acceleration is equal to v minus v initial over t, or as t is equal to v minus v initial over a. This is just solving for a different variable. In addition, you might see different symbols, like delta x, which equals to x minus x initial, u, which is equal to v initial, and s, which is equal to displacement. It's up to personal preference, but College Board uses delta x, v initial, and displacement. Now, in projectile motion, which is what we'll get into next, your x direction is going to be constant velocity, and in your y direction, you will have constant acceleration. In the next video, we'll be going over projectile motion.